Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of line in R3. So as per the problem, determine the coordinates of three different points on each line. So let's start with the first line. So this equation is given in symmetric form. So in order to find three different points that lie on this line, we should convert the symmetric form to parametric form. And for that, we'll have to use a parameter for this equation. So let's assume the parameter for this equation is t. So we should set each part of this equation equal to t and then solve for x, y, and z. So let's start with the x part of the equation. So we should cross multiply the 3. Now we can subtract 1 from both sides. So this is the x equation for this line. Now we can find the y equation, and for that we'll set the y part of the symmetric equation equal to t. We cross multiply the -1. And now we can add 2 to both sides. Now we can work on the z equation. We can cross multiply the 4. So this is the z equation. So the parametric equations for this line are now we can find the 3 points that lie on this line by using 3 different values of t. So we can start with t equals -1. I get x equals -4. Now we can sub in t as -1 in the y equation. I get y equals 3. Now we can sub in t equals -1 in the z equation. So the first point on this line is now we can find the second point on this line, and for that we can use t equals 0. So let's start with the x equation. I get x equals -1. Now we can sub in t as 0 in the y equation. I get y equals 2. Now we can sub in t as 0 in the z equation. I get z equals 0. So the second point on this line is now we can find the third point, and for that we can sub in t equals 1. So let's start with the x equation. I get x equals 2. Now we can sub in t as 1 in the y equation. I get y equals 1. Now we can sub in t as 1 in the z equation. I get z equals 4. So the third point on this line is 2, 1, 4. So these are the 3 points that lie on the first line. Now we can analyze the second line. The second line is also given in symmetric form. The x part of the equation is not in symmetric form because the x component of the direction vector is 0. That's why the x equation is given in parametric form. Now we have to write the y part and the z part of the symmetric equation in parametric form, and for that we'll have to use a parameter, and we can use the parameter m for this equation. We should set y part of the equation and z part of the equation equal to m and solve for y and z. So let's start with the y part of the equation. We can cross multiply the 3. Now we can add 2 to both sides. So this is the y equation. Now we can find the z equation. We can cross multiply the 5. We can add 3 to both sides. So this is the z equation. So the parametric equations for this line are now we have to use 3 different values for the parameter m to find 3 different points that lie on this line. So let's start with m equals -1. Since there is no m term in the x equation, x will be equal to -4. Now we can sub in m as -1 in the y equation. I get y equals -1. Now we can sub in m as -1 in the z equation. I get z equals -2. So the first point on the second line is -4, -1, -2. Next, we can use the m value 0. The x value will stay the same. Now we can find the y value. I get y equals 2. Now we can find the z value. I get z equals 3. So the second point on this line is -4, 2, 3. Now we can find the third point, and for that we should sub in m as 1. The x value will stay the same because there is no m term in the x equation. Now we can sub in m as 1 in the y equation. I get y equals 5. Now we can sub in m as 1 in the z equation. I get z equals 8. So the third point on this line is -4, 5, 8. So these are the 3 points on the second line. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.